So we are moving ahead with the second example, still about solving simultaneous equations, and again using elimination method. So we want to do this and we see. The question goes, solve the simultaneous equations 3x plus y minus 2z equals 7. Then the second one is saying x plus 7y minus 5z equals 13. Then another one is 2x minus y minus 3z equals 3. So we are dealing with now 3 equations. I said before you proceed, first look for those ones which have got the common variable, such that you can try to, which can easily be eliminated. So this is the first equation, this is the second, this one is the third. So what you're going to do, I'm going to say, what if I say equation 1 plus equation 3? My interest, you have seen there is y and this is negative. So if I add them, 3x plus 2x, I come out with 5x. Y plus negative y, it disappears. Negative 2z plus 3, negative 3z will get also minus 5z equals 7 plus 3, we also get a 10. Still, 5 can go throughout. I remain with what? Dividing so by 5, I remain with x minus z equals 2. So, I said this is equation 4. I can say this is equation 4. Still, I also look out for the one which I can easily eliminate. Again, I look at equation 1. I can also look at equation 2 and 3. Yes. I also say solving Roman 2 and Roman 3. So I've got x plus 7y minus 5z equals 13. Then another one is 2x minus y minus 3z equals 3. Which one can we can eliminate? Still we can eliminate our z. I want to eliminate z. So what am I going to do? I put a 3 up, then I put a 5 down. So 3 times x, I'm getting 3x plus 21y minus 15z equals 39. We also come this times this, I also get 10x. Then I say this times this, it is minus 5y. 5 times this, it is minus 15z equals 5 times that, we get 15. How can I eliminate this one? Through deducting. I subtract. 3x minus 10x, I get negative 7x. 21 minus 5y, I get plus 26y. This and this disappears. I move to this one. 39 minus 15, automatically I will get a 24. So from there, this one, my interest was to eliminate y because I want them to connect on the same. So we did not see care from that which one to eliminate. So our interest is to have a equation related with x and z. That means from this one I'm going to eliminate y. I can say solving 1 and 3, I've got x plus 7y minus 5z equals 13, and we had 2x minus y minus 3z equals 3. Our interest is to eliminate y, so that we can remain with x and z, so that they can connect with equation 4. So I'm going to put up negative 1, then down 7. Multiply so out we get negative x minus 7y plus 5z equals negative 13. Multiply so out by 7, here we get 14x minus 7y, again minus 21z equals 21. How can I remedy this one? We subtract. This minus minus, I get minus 15x. This one disappears. I also get this minus minus, I get plus 26z equals negative 13 minus 21. I get negative 34. So, from there, we have got this one is in terms of z. I can call it equation 5. Then we are going to be solving equation 4 with 5. Even I'm free even to use elimination substitution method. You can say solving 4 and 5. And from 4, I can make any variable the subject. You can make x the subject or z, but let me make x. From 4, x becomes 2 plus z. So, from there, we substitute it. You can say put x in 5. What is equation 5 saying? I've got negative 15. Where there is x, you put that value. Negative 15 into 2 plus z. That's why I said that they work hand in hand. Elimination works hand in hand with substitution. Plus 26z equals negative 34. So, can we open the brackets and correct like terms? Negative 15 times 2 get negative 30 minus 15z plus 26z equals negative 34. So, we collect like terms and we try to rearrange. So, negative 15 plus 26z, we are automatically getting what we call 11z equals, we take the other one, negative 30 plus negative 34. I'm automatically getting what we are calling this one plus this. When it goes up comes, I'm automatically getting negative 4. So what is z alone? Z alone becomes negative 4 out of 11. So after getting z alone like that, we are free to substitute in any other equation so that we can obtain the best in it. So we will substitute in another one. We can say in equation in x equals 2 plus z. So what is x? Becomes 2 minus 4 out of 11. Can we get the LCM? The LCM is 11. So this one becomes 22 minus 4 out of 11. What is 22 minus 4? That is 18 out of 11 as the value of x. So we need now to get other value of y. We are free to substitute in any equation of our choice. So we can substitute in an equation, can put maybe in equation 1 or equation 3. So we can put in equation 1. Can substitute in equation 1. Can put it in 1. And our equation 1 reads 3x plus y minus 2z equals 7. Our interest is to have y. Can even first make y the subject. Y becomes z plus 7 plus 2z minus 3x. So this one becomes 7 plus 2 into. Do we know our z? Our z is already negative 4 out of 11 minus 3 into. Do we know x? 18 out of 11. So can we open the brackets and we correct the terms? This becomes 7 minus 8 out of 11. This one becomes minus 54 out of 11. So this is y. So can we get y? Y becomes 77 minus 8 minus 54 out of 11. So if you try to subtract on your calculator, we can easily say 77 minus 8 minus 54. We are coming out with 15. So our y is the same as 15 out of 11. So you can conclude therefore x equals 18 out of 11, comma, y equals 15 out of 11, and z equals -4 out of 11. That's how we solve such a kind of simultaneous equations.